So here we're looking at 2022 complex numbers. So the complex number Z1 is shown in the diagram below. Here we can see when you're plotting these, you've got a real part and an imaginary part. So a complex number is anything of the form like 2 plus 3a. Generally it is in the form a plus ba. So your real numbers go here, your imaginary numbers go on the y-axis. So write down the values of Z1. Now Z1, we're minus 2 across and we're minus 3 down. The way they write that is minus 2 minus 3a. And then this thing Z1 with a cap, I always say Z1 conjugate. What you do for the conjugate, change the sign of the imaginary part only. So change the sign of the imaginary part, it becomes minus 2 plus 3a. Plot and label it on the diagram. So minus 2 plus 3a up here. And then label it Z1 with a cap on top of it. Next thing, Z2 and Z3 are two other complex numbers. Plot and label Z2 and Z3. So Z2 is minus 5 plus 3a. So minus 5 plus 3a. There's our Z2. And 4 minus 2a. So 4 across, 2 down, we dot, label it Z3. So that's that bit done. Write Z2 minus Z3 in the form. So anytime we see a minus here, we're going to have to put in brackets. Otherwise, we'll forget to change the sign of both terms of Z3. So sub in our values. Our Z2 is minus 5 plus 3a. You can have brackets around this if you wish. Minus, and this is the bit where we need our big dirty brackets. Our Z3 there is 4 minus 2a. If we didn't have the brackets, we're guaranteed we just write down minus 4 and we forget to change the sign of this 2a. So we work that out. Minus 5 plus 3a. It's like multiplying by minus 1 if you wish. Give it as minus 4. Minus and a minus makes a plus 2a. And then add together the real bits. Minus 5 minus 4 is minus 9. And our imaginary bits plus 5a. And hence find these things here. So we see two big, long, dirty lines, straight down lines. And what that means is the modulus. Once we see hence, we use our previous answer. Now, in order to work out the modulus, which indicates the distance from the origin, try and memorize this formula. Square root of a squared plus b squared, or the square root of real squared plus imaginary squared. So here, it's going to be the square root of minus 9 squared plus, it's always a plus, my b there is 5 squared. We don't need the a because it's just a number answer. How far it is from the origin, how far it is from 0, 0. So we work that out, we get the square root of 81 plus 25. Fire that into your calculator. The square root of 106, and it doesn't simplify down anything else, so that's it in third form. And investigate if, so it's not say show it, is it? We're going to say, is it a solution of this here equation here? So the easiest way to do it is probably just sub it in. So anywhere there's a z, I'm going to fill in 4 minus 2a. Alternatively, use your minus b formula and see is that going to be one of the answers. So there's more than one way to skin a cat. Once we see something squared, write out that bracket twice. And then maybe multiply out these bits here. Bust your brackets, split your brackets. Every way you multiply out those. Alarm bells are ringing. Once I see a squared, I sub in minus 1. Now, it might tell me that. It does. Usually it tells you somewhere in the question. So there it says a squared is minus 1. Remember, complex number, so it's only ever just a real bit and an imaginary bit. So minus 4 times minus 1. And just keep taking our time and see does it work out to be 0 is equal to 0 if it is a solution. minus 8a minus 8a plus 8a. What's that? Minus 8a minus 15a. And then I've got 4a squared, similar story. So I've got my 16. My a squared there's minus 1 plus 4 is equal to 0. There you go. I'm left with 16 minus 15a. Therefore, it's not a solution. Next thing here, wee bit of algebra. Solve for the value of x. So we've got brackets. Multiply them out. And what do we have here? 2 times 3x is 6x minus 10. That 8's not in a bracket. It's equal to 4x minus 5. And maybe tidy it up. Each side first. So 6x minus 2 is equal to 4x minus 5. Now I want all my numbers one side, letters the other. Comes across, changes the sign. So I've got 6x minus 4x is equal to minus 5 plus 2. 2x is equal to minus 3. X equal to minus 3 over 2. Or minus 1.5. Whatever you wish. This thing, right? 3 to the power of 4 to the power of 5 over 3 to the power of 6 in the form 3 to the power of k. A lot to be said there. Now, there's rules of indices in your formula book, and once we have a power to a power, we multiply. So 4 times 5 is 20 over 3 to the power of 6. If there weren't such big numbers, I'd write out 20 of them 3's and you'd see what would happen. Then, what we have then is, there's another rule there that says like a over m over a to the n is equal to am minus n. So once we've got the same base, we just subtract the powers. So 20 minus 6, 3 to the power of 14. And the third bit of that, simultaneous equations. So what you want here is the same number of y's, different sign. That's generally my go-to. Same y's, different sign. So in the top line, I have 2 y's, and in the second line there I have 5. So what I'm going to do is going to multiply this top line by 5, and this bottom line by 2. It's the opposite number to what it has. But if I just do this, I'm going to end up with plus 10y and plus 10y. So one of them needs to be a minus. So just say I'm going to multiply this here by minus 2. So the same number of y's and different sign. I multiply that full line. People often forget to multiply the 1 at the end. That full line gets multiplied. So 5 times 3x, sorry, touch screen's a disaster. 15x plus 10y is equal to 5. And then minus minus 14x minus 10y is equal to minus 2 times minus 2 is 4. Then I've got the same number of y's, different sign, so I'm good. There you go. 15x minus 14x is 1x is equal to 5 plus 4. I know it's a plus because there's no sign in front of it. 9. Once I have my x, sub it back in. It doesn't matter where you sub it back in. I generally fire it into the top line there. If you're right, you could sub it into any of those 4 lines there. This, or this. So you've got 3x plus 2y. Instead of that x, I'm going to sub in 9. Plus 2y is equal to 1. 27 plus 2y is equal to 1. 2y is equal to 1 minus 27. 2y is equal to minus 26. Y is equal to minus 13. So my x is 9. My y is minus 13.